constructor, yes. Okay, so constructors are public, so other classes can build these objects typically. And in here, I'm going to pass in a name parameter, and in here, assign the name instance variable with the value, the reference to that name string. All right, so that's probably kind of good enough to start, right? Now, we're going to make another class, a student class, and I want this to inherit from person. Basically, I don't want to have to go in and make my own string name because, you know, I could, but, you know, I'd rather take advantage of this definition of a person and say a student is a kind of person, and I want to get that name stuff for free. That's the basic idea of inheritance, showing relationships between things. And so instead here, I'm going to use the Java terminology and say up here extends person. Okay, so that's now saying, that basically says student is a person, student is a subclass of the superclass person, student inherits from person. Those all make sense from that context there, okay? Now what that actually does to this class is a little harder to winnow out, and it takes some time to understand all the ramifications of this, but basically I'm inheriting from person. Now, let's see, what do I want to do next?
Why is it mad at you?
Yeah, it's mad probably because there's some constructor issues we need to deal with here. All right, so, okay, so let's, what else should a student have besides a name? So it's going to get name for free. And what else defines a student? Grade, major. You're on the same page as me. Tuition due. All right, so we've now added another instance to student. And now I want to construct a student. And again, a student is both a person and a specialization, the student. And so our constructor needs to somehow do both sides of that. What am I going to need in this case to make a student? Like what information do I need to initialize a student properly? So, someone raise your hand on it. Oh, you're all talking it now. Okay. I need a name. And what else do I need? I need tuition due. I need both those things, right? So it's a little bit weird. You only see one thing here, this tuition due, but there's really two chunks of information I need to create this. So tuition due, and in the constructor, let's really complain about a lot of stuff here. Okay, okay, just calm down there. Okay, so I'm going to first of all set up my tuition due to be the passed in tuition due. And again, just to kind of, you know, keep in mind, this is really the same as this dot tuition due, right? This is an instance variable, and we can access it through this, or we can just sort of do it implicitly and let the compiler figure out where it belongs. Maybe I'll leave that there for a minute. Now, the problem is, how do I get to name? So in person, I have this name, and I want to initialize it. But I don't actually have access to name because it's private in the superclass. And private is private. You can't get to it. Okay? So what's another way I can set this name value, do you think? We don't have a lot of choices here. What do you think?
Can you use a person since you have a public person in your other class?
So can I use a person? I'm not composed with a person, right? Like I don't really have a person here, but I am a person. So I think you're kind of in the right direction here. But what else can I do?
You can call the person class.
Call the person class. What does that mean?
Try to get the variable name out of the person class in the class.
So I can't get the variable. I can't get the instance variable name out of it directly here. You're good idea.
Use super.
Okay, so I want to somehow force this constructor to trigger from the student, and then it initializes name for me. So if I can somehow get this code to work, which is public, then I can get name initialized that way, all right? And there is a mechanism to do that. Basically, in a class that inherits from another class, and in that subclass's constructor, you need to call the super constructor. In other words, we're not going to give a name here like person, but super means the thing I inherit from, which is person, and I can call that constructor like this. All right, so it's a little bit funny. Now there's this super thing. Why not call it person? Why not call it person here? Besides the fact you're not allowed to do it. Why did Java make up this super word instead of person, do you think? Any ideas? So this is specific. This is general. Why go for this sort of like vague super thing?
Would it get confused if you're trying to like declare a person?
There may be some conflicts they're trying to avoid that way, but
Could you have like a class that inherits from a class or another class?
well, you can get a chain of inheritance for sure. And I'm not sure this really directly solves that problem, but I'll just say maybe one reason, I don't actually totally know, but let's say I want to swap out person for a person or something like that, right? It's sort of a similar thing, but not exactly the same. It might be nice not to have to go through and fix up all the person to a persons and just leave it, say, whoever I inherit from, you know, do your magic kind of thing, okay? So keep it a little more general. So, okay, so if we have this, let's see. Let's make a person in here. That's what I know. That's what we know about. So person me equals new person David, and in student, let's also make a student me equals new student, and I'm passing in a name and some number. All right, so I got two me's. Let's get rid of this person here. All right. So if I run this, not much is going to happen except hopefully not die. So it's nothing happens. You know, it's good. Let's try to figure out how to see what's going on a little bit more with this. All right. So right now you're sort of vaguely believing that maybe there's some name associated with this. And if you want to think about this conceptually, you can kind of think of a student. And what does the student object have inside it? It has a place for the tuition thing, some number. And then it actually has another object in it. So it's not really that it's just stealing the instance variables from person. It's really like there's an actual another kind of object in here. And that other object there is a person that has a name. Okay, so that's sort of maybe a closer way of thinking about it, that it's sort of an object inside an object when you inherit from it. All right, so we've constructed this thing. Let's make here, if I try to print out what's in me, what am I going to get here? So someone tell me again, what's the process when I say print this thing? What really happens kind of underneath? Something that you're using in your dynamic array class? Yeah.
It's just going to print like the reference address unless it has a toString method.
Okay, so the default behavior for printing an object is that it prints out that sort of reference string hash code thing, which isn't that useful unless you you create your own toString method. So right now, we have this, it prints out, come on, give me that little bar. Okay, so it says I have a person object instance, and it has this magic number associated with it, right? And in order to get something more useful, we want to make a toString method. And in here, we want to return a string that gets printed out during these print statements. So I could print out just some basic information in here, like that. And when I run it now, it prints out name David. Okay. So let's do something similar for student. So here's student, and I want to make my public string toString. And in here, I want to print out the values that I'm storing. So what's the value that I'm storing?
Name and tuition.
Those are two things, name and tuition, yeah. So I can print out tuition easily enough. Tuition due. And tuition due. Tuition due. What's wrong with this thing? Maybe it's just, okay, semicolon. And if I were to print out me here, system out, print line me, and I print it out, I get tuition due, but I'm not just a number, money owed, right? I'm also a name. So let's again try, futilely perhaps, to print out name, and it's going to complain me and say the field or instance variable person.name is not visible. In other words, that's not accessible to me. So there are some things I can do to fix this, but it may cause other problems. So for example, what could I change here to allow me to use name in here? What's something I can change in person here? Someone was saying it, just say it a little more boldly.
Change private to public.
Okay, make it private, make it public. Make it public. And if I do that, then all of a sudden name is accessible outside of the class, and I can print it. Now again, that's dangerous, right? It's dangerous because all of a sudden I can do dumb things to it, and then I've kind of like cracked open the class, broken the encapsulation, and instead I can do spiteful, mean things in here. So we don't want to do that. Public's not the greatest idea. Yeah.
What about changing it to protected?
Okay, so we've talked about public, and we've talked about private, and there is another access called protected that allows you to be private for other classes unless you inherit from that class. So student inherits from person, and it can access the protected instance variables of that class. All right? So that's another thing you can do. What do you think of that? Do you like protected? Is it handy? What, do you not like it? Is it awesome? I can do this cool thing, protected. Any opinions from a software engineering point of view? What do you think?
Well, if they change the person class to have a name first and a name last, then you'd have to rewrite all the code.
So changing stuff inside, we've broken the encapsulation. Another problem is that I might think I'm inheriting, but I can still do mean things here, right? And so it really has the same troubles that making it public has, just for a more limited scope. So I'd be cautious sort of throwing protected around just because it makes your life easy. All right. What else could I do to get that name out of here?
What about calling a two-string super?
Okay, so well, let's hold up for that. So one more idea I want to hear. So we know one way to get this value out of this class.
Make a getter.
Make a getter for it, right? And again, I think that still has some problems, but it's not as bad I'm really returning a copy of that string, and so I'm not able to change it. So getter would help. But there is a more, there's another mechanism to do this, and that is I can access things, public methods in the class I inherit from through this super notation that we're using already. So I can say super, super to string, and that calls the toString method in the super class. Okay? And since that returns a string, I can then concatenate it with this other stuff here. So this accesses that toString without sort of causing other problems by making things public and so on. Now notice there's actually something a little more subtle going on here. And that more subtle thing is that in person, I have a toString class. And in student, I have a toString class. And they both look exactly the same. And for example, if I were to try something like this, return, it's going to complain to me and say, duplicate method toString and type student. All right, so you're not allowed to have two versions of the same method or the same instance variable name in a class because you get a conflict. The compiler would not know which one of these ones to use when you say give me a toString, right? So you can't do that. Now it seems funny in a way that I am allowed to do it because without this, actually I don't think I even showed this part. Okay, so if I comment that out and I did a print line on me now, what am I going to get out of this? It gets the toString from person, right? I inherited it. So there are two versions of toString hanging around here when I make this. But when you're in a subclass, you're allowed to what's called override the super class method. So all of a sudden, well, before we're not allowed to have two things with the same name and the same number of parameters. Now, because we're inheriting, it allows this mechanism of changing behavior. And that's because usually you want to have something with a similar name, but with some new specialized behavior. In this case, the specialized behaviors that we're adding in the tuition due is along with the name. Okay? Now, in this case, I also want to take advantage of the code that's already written up in the superclass, and so I'm going to call the toString for it rather than reinventing the wheel here and writing it again. So already we have this sort of, just this inheritance here, which seems kind of nice and easy. We're going to inherit from this, and we're going to use its code, and it's going to make life, simpler. We're not copying things around. Also, there's sort of this complexity. In the constructor, we're having to initialize the object that we're inheriting from. And then in methods, there are copies of methods, but we're allowed to have two of them hanging around, and it uses the one that's the one that's closest to the type of the thing that's calling it. And then we can also access the other one through the super thing. So there's all these sort of little details that makes inheritance be a little tricky to get right when you're working on these things. So just be cautious about that. All right, so questions about that, first of all. So we inherit, we get we have storage for the instance variables from the parent class, but we don't have direct access to it necessarily. We can construct it with a super constructor, and we can access methods in the parent class through this super dot notation. Okay, so that's the main things I want you to get out of that part of this here. But any questions? Yeah.
Is the overriding the super on the toString, is that basically the same thing we're doing when we create a toString in general, where we override the whole Java?
Yeah, okay, so that's a nice segue into a few more little things. So, first, all classes inherit from this default object class in Java called object. And we'll learn more about what that does for us when we talk about this polymorphism concept. But basically, these object classes all have a equals method, and they have a toString method. And they're kind of boring. They just say, for the toString, print out the reference. And for the equals says, is it the same reference? And so most things will override those to provide sort of useful methods for their particular class. And we saw, I showed you a little while ago, overriding the equals, and it didn't quite make sense because we were like casting it as a object type and doing some weird stuff to it. And this is sort of what's going on here. These all are, when we make a class, they all inherit from object, and they already actually inherit a certain number of things that we're just sort of used to using at this point. Okay, access, I want to show you really briefly. We saw how public, basically everything can access a public method or instance variable, and again that makes it both powerful and dangerous. Private, only the class code itself can access stuff that's declared private. If you call it protected, then the class can get to it, and the subclass can get to it, and actually it's called the package can get to it. So if you're in the same package, you can access it. And if you don't give any modifier, which to be honest, I'm getting better at it, but I used to always forget to put public or private or anything in front of it, it still has some meaning. It means that the class can get to it, and the package can get to it, but not subclasses. It's sort of a weird thing. It's not a common access control in Java to have that, but it does have a certain form to it. All right, so these are the main ones we care about: public, private, protected, and then when you forget something, it still has some meaning. And you kind of have to think about it in all these different categories. The class itself can access it, the package can access it, the subclass can access it, or the world can access it, okay? So all those have different ramifications when you use them in different ways. Now, one other little thing, when we're overriding a method, there's this thing you can write above it, @override, called an annotation type, that tells the compiler that I'm expecting that there is this same method in a class I inherit from. And you're changing that behavior. Now the reason this is useful is because let's say you do a typo and I said toString, all lowercase letters or something like that, and I didn't actually override the toString I wanted to, then the compiler would say, hey, you think you're overriding something, but guess what, you're not. So look at it again, kind of thing. And so this override thing is kind of handy just to keep you on track if you forget what's going on with the superclass. And it allows you to kind of monitor whether you're actually doing things the way you expect. Okay, we inherit from object, and I'll use this next time, but there's this thing called instance of that lets you know whether you're a particular class. Okay, so if you want to know if something is a student class, you can say is S an instance of student, and you can use that to do various kind of behaviors. And so in summary, composition, composing things using instance variables is sort of the easy way to get power into your class, and we're used to doing it that way. And that's not a bad thing to do. If you use inheritance, it's basically showing classes are related, and we'll see more powerful uses of inheritance not next week, but after break. But I'd say that designing these relationships between classes is a lot harder in some ways than just sort of saying, I would like a tire, put it in my class. Also, you're trying to figure out how they're connected together and how they're related, and things can kind of go a little bit wrong. So, this is actually a really easy assignment. It's going to be worth 50 points. It's going to be due not obviously during break, but the Friday or Thursday after. It's to make a generic version of our dynamic array class. So it can handle lots of strings, but integers, doubles, all those kind of things. Very easy, just replacing string with T. And then we're going to make an inheritance thing where I have a base class dynamic array, and you're going to make a different version that inherits from it and only overrides one particular method to change its behavior, basically how it grows when you run out of room. And you'll do a little investigation, like on speed test kind of stuff with it. And there's a Runestone exercise. All right, so have a good break, everyone. And look for that. I'll send out an announcement.